Today we will talk about the elasticity concept. Let's look at the definition first. The idea of elasticity is it's a measure of responsiveness. So we said that even though, let's say, a demand curve such as this is linear, right? It's a straight line. So the slope of the line, that means the rate of change of the line, is constant because it's a straight line, so it's going to be constant. But the elasticity of this line is not in fact constant. So why that is the case, that the elasticity is not in fact constant? We said one of the clues could be the utility idea that we explored in the last lecture. As we have more of something, and this is quantity demanded, as we have more of something, the utility for that something diminishes. Okay? Meaning the utility declines. Elasticity is the measure of responsiveness. So how much a person responds if the price declines. So if the price declines to this point, let's say from this point to this point, then what would be the response? It could be because if you have more of something, I mean the utility for that diminishes. So price goes from here to here. You have actually excessive amount of quantity that you can buy. Now this is applicable both in case of micro analysis, that means for an individual, and for an entire market. The logic remains the same. You have to just extend the logic that is applicable for an individual to the entire market. The logic is exactly the same. So if you have more of something, the quantity, the utility for that something actually declines, and that's the basic idea behind the non-constant elasticity of a linear curve. Okay. So measure of responsiveness of quantity demanded or quantity supplied, both. Now why, I mean, would that be applicable on the quantity supplied as well? The idea of utility, yes, it would be. It's the same logic. As price increases, more and more suppliers are willing to demand, are willing to supply in the market. Why is that the case? Because supply curve is nothing, we'll see, is nothing but the cost line. Okay. And it essentially means that for some suppliers it's not really feasible to supply at, let's say, this price. If the price moves up, more and more suppliers join in. From a point of view of individual supplier, an individual supplier also faces a cost line. For him to supply this much at this price, he'll have to produce this much. Why not more? Because the costs don't permit it. If the price goes higher in the market, he can in fact incur higher costs and hence supplying more. So the same logic extends the logic of utility. Here the idea is that of cost. So cost can be related to utility. He'll have to give up more to produce more. So in order to give up more, he'll have to get in exchange of that giving up. In exchange of that giving up, he'll have to recover his costs essentially. So not to make it overly complicated, my point is, when the question emerges why elasticity is not constant, even in a linear curve or on a linear curve, is because diminishing marginal utility. Okay. So, however, calculation of elasticity is really simple. If you, let's say, want to find out the price elasticity of demand, all you have to do is the percentage change in quantity demanded divided by, remember this delta symbol is the symbol for change. So percentage change in quantity demanded divided by percentage change in the price of that product. So let's say quantity demanded for X, then price for the product X. That's all there is to it. Now how we calculate this percentage change differs slightly. There is something called as a midpoint method. How do we calculate a percentage change? So let's say the price goes from 10 to 15. Okay, price goes from 10 to 15. What is the percentage change? Well, the problem is, if you say the price goes from 10 to 15, you're essentially saying that this is the direction. But what if this is the direction? Elasticity can measure both, because it's not saying the responsiveness in quantity demanded when the price increases. It's saying the responsiveness of quantity demanded or supplied when the price changes. The change, okay, how much a quantity demanded or quantity good demanded of a good responds to change in the price of that good, not increase or decrease, but just change in the price of that good, computed as a percentage change in quantity demanded divided by percentage change in price. That's exactly what we did here. But if the change is bidirectional, that means it can either go from 10 to 15, or we can also calculate elasticity when price goes from 15 to 10. In both these cases, actually the percentage change would be different. If price goes from 10 to 15, the percentage change is 50%, because the change is 50%, correct? 5 is increased, so 5 is 50% of 10. On the other hand, if price goes from 15 to 10, that means the change is still 5. Change is still 5, but it goes from 15 to 10, so the actual percentage change would be 33%, because 5 divided by 15 is 1 by 3, which is 33.33%. This 3333 extends infinitely. So that is why what economists have suggested is that we calculate something what we call as a midpoint method. Okay, what is that? Well, simply let's write our example afresh. The price may either fluctuate from 10 to 15 or 15 to 10. So the midpoint method suggests you take the average of both these prices and divide, or just take a point in between. What would be the point in between? Right? The point between 10 and 15 would be 12.5. So 12.5. Now let's say the quantity demanded changes from 50 and the price was 10 to 40. Alright, so what is the midpoint? 45. as the midpoint. Now what they're saying is you can calculate either way the percentage change, whether you're calculating from 40 to 45 or 50 to 45, because it's a midpoint, it's a much more accurate measure, right? So how do we really calculate it? The way you can calculate it is, once we know that there is this midpoint, if we now actually consider the total change, the change between 10 to 15 is 5, and the change of quantity demanded 50 to 40 is what? 10. So to calculate the percentage, we have to take 45 as the base, correct? So in that case, if we have midpoint as the base and the change is whatever the change is, 50 to 40 or 40 to 50, it's both gonna be 10, 10 to 15 or 15 to 10, the absolute change is 5. So the calculation, I mean by what percent it has changed, it would be 5 by 12.5, and this is for price, and for quantity demanded it would be 10 by 4.5, I'm sorry, 10 by 45. So this will be 1 by 4.5, and this will be some fraction. So once we have that, we can implement our formula, which was percentage change in quantity demanded divided by percentage change in the price of the commodity. That's all we need to do. So we can put these numbers over here, something like, okay, I'm running out of space, so let's see, we can squeeze it somewhere in between, see if we can. Okay, so percentage change in price was 5 by 12.5, and percentage change in quantity demanded was 1 by 4.5 divided by 5 by 12.5. Alright, so it will be 12.5, this thing will go over there, so it will be 1 by 4.5 multiplied by 12.5 divided by 5. Alright, so this is how we can, this is separate. Okay, this is how we can calculate it. So we'll need a calculator for it. However, the decimals will go away. So it will be 45 multiplied by 5, correct? So will be 5 to 9 to the 10 plus the 25, 5. So this comes out to be, let me write in another ink, this comes out to be 5 divided by 9. So the answer is 5 by 9. Okay, so that means 5 by 9 is definitely what? Less than 1. Now this essentially means that this curve for which we were making this calculation, this curve is not elastic. Okay, this curve is not elastic. How so? Because if 5 by 9 is the elasticity that we calculated, it was less than 1. So, and this was our elasticity, which is represented by E. And if it is price elasticity of demand, we put a little subscript P over here to signify its price elasticity of demand. Alright, anyway, elasticity when less than 1 is not elastic. That means its response will not be very good. It will be less responsive. If elasticity is equal to 1, then it's called as perfectly elastic. Why? Because it will show the response exactly in a way the price has changed, exactly in the same proportion as the price has changed. And if elasticity is greater than 1, then it is highly elastic, or just simply elastic. Highly elastic if it is quite high, let's say 4 or 5 or something like that, then it's highly elastic. Even 2 is actually highly elastic, because in this case, if price changes by 1%, then the quantity demanded will change by 2%. That's what elasticity as 2 means. Okay, all these will be highly elastic. This will be quite elastic, we can say. Okay, so whether we call it highly elastic or elastic, that's a subjective decision. But one thing is for sure, that when the price changes, the response in quantity demanded will be more than proportionate. Okay, more than proportionate. So this is all there is to it. Now we can look at the elasticity of supply. But before we do that, let's look at a couple of diagrams and try to determine whether the elasticity, how can we just look at a demand curve and determine what the elasticity would be. If it is perfectly inelastic, elasticity equals to 0. If it is inelastic, perfectly inelastic, okay, when elasticity was less than 1, it was not elastic or inelastic, correct? If the elasticity is literally 0, that means there is no responsiveness in the quantity demanded, doesn't matter what the price change is. So that would have to be a vertical line like this. Okay, that means the quantity demanded is fixed at this point, doesn't matter how much the price changes, how much change in price is observed, it doesn't matter. The demand, quantity demanded remains exactly the same. So this is one of those things, exceptional cases. Okay, another one is inelastic demand, not perfectly inelastic but inelastic. That means the responsiveness in quantity demanded is not that much. And as you can see, if this is a vertical line, that means if this line was something like this, would it be inelastic? Yeah, because the distance, the angular distance between this line and this line is not that much. If it is this much, it still would be a bit inelastic. If it is this much, that means sort of 45-degree angle, then we can say, yeah, it would be elastic, if not highly elastic. So just by looking at the demand, see, this one is, we can think of this one as a line which is kind of like this. That means it's not, if we can relate it to this one, it's not even this much inclined, but slightly like this. Okay, like this. That means it's not deviating that much from this perfectly inelastic demand. And we can look at this demand curve and we can comment that this is inelastic demand. Elasticity is less than 1. Let's look at another one. If you look at this one, here actually it's quite opposite to the straight line. It's quite opposite to what that vertical line was. It's in fact very much horizontal, and that's what this means. If a demand line or a demand curve is horizontal like this, flat to y-axis, then that means even a slight change in price will affect the entire demand curve. That means demand curve will actually go from here to here. If the price increases from here to here, in case of increase it's not, this is not true. In case of increase that won't be the case, but in case of decrease that would be the case. So if the price decreases, because we already know that if the demand only increases when the price decreases, so in case of price going from below $4, they'll buy any quantity. So we'll say the demand is perfectly elastic because they are buying exactly as much as before. And this, if you look at this demand, they are essentially, again, these are exceptional cases. This is not really true, but the point is the graph, the mathematical side of it is saying if the demand curve is like this, then an infinite quantity will be demanded and still an infinite quantity will be demanded. So the percentage change between infinity and infinity is infinity, and that is why we are saying it's perfectly elastic. At any point above $4, as the graph shows, the demand is null. There is no demand, and in that case the perfectly elastic demand, the infinite demand, will come down to zero. That means there has been an infinite decrease in price, and that is why whether the quantity changes negatively or positively, we think of elasticity as an absolute number, and in that case still it will be a perfectly elastic demand. That means elasticity actually equals infinity, which from a common sense perspective doesn't make a lot of sense, but from a mathematical perspective it makes perfect sense. Here, however, because it's sort of a flattened curve, it's closer in the shape with the horizontal, this kind of line, rather than this kind of line. So it's not this kind of line, it's not the vertical line, closer to vertical line, it's closer to the horizontal line, and we can say elasticity is greater than 1 just by looking at the shape of the demand curve. And also, as the example presents, when the price goes up from 4 to 5, a slight change, quantity changes quite a bit. That means it's almost 100% increase, and even by a midpoint method we can say 75. So 50 divided by 75, this is the percentage increase in each of the case, whereas it's the midpoint would be 4.5. So 1 divided by 4.5. So this is 2 by 3, which is 66% approximately, greater than 66%, and this is what we get rid of this to 9. So this is much less. This is approximately 22%, correct? So this is highly elastic because the percentage change in price, like percentage change in quantity demanded, is much higher than the percentage change in price. This will be highly elastic. Okay, the same logic will be applicable on the supply curve. If it's a vertical line, then perfectly inelastic supply. If it's a line which is closer to the vertical line, something like this, as you can see, if you move this line slightly here, yeah, just a little bit, what you have is this kind of a curve, and again you have an inelastic supply. Same idea. What will be the price elasticity of demand? Well, that's simple. What was price elasticity of demand? Well, price elasticity of demand was quantity demanded divided by percentage change in price. The same idea is applicable. The only difference would be this much, the quantity supplied divided by percentage change in price. That's all. The percentage change in quantity supplied divided by percentage change in price. If the elasticity of supply is less than 1, then it's not elastic. Elasticity of supply is equal to 1, then it's perfectly elastic. If elasticity of supply is greater than 1, then it's elastic, or much greater than 1, then highly elastic. Right? What about perfectly elastic? Well, if it is perfectly elastic, then elasticity would be infinity. And if it is not elastic, inelastic, perfectly inelastic, then elasticity of supply would be 0. So the same concept that we used in elasticity, price elasticity of demand, that's the same concept we're going to use in price elasticity of supply. Now in the next lecture, continuing the idea of elasticity, what we're going to look at is how the producer makes a decision to whether increase the production or decrease the production depending on the price elasticity of demand. That's all. That's gonna be our next topic, because that would be its application. Right? Why do we even need to find the measure of elasticity? So from producers and consumer point of view, we'll look at the applications of elasticity in brief. Alright, thank you.